10.1.3. So now we're going to learn how to use the second derivative test in order to determine the relative maximum and the relative minimum of a function. Suppose we have the second derivative of fx that is continuous on an open interval that contains c. We have the first case where if the second derivative of fx is greater than 0, which is positive, then fx has a relative minimum at x equals c. In the second case, if the second derivative of fx is less than 0, which is negative, then fx has a relative maximum at x equals c. However, if both the first derivative of fx and the second derivative of fx are equal to 0, the test fails. We can say that it is inconclusive by using the second derivative test. Thus, we must use the first derivative test in order to find the relative maximum and the relative minimum of the function. So now let's have a look at example 3, question number 1 from the lecture notes. By using the second derivative test, find the relative extremum of the function fx equals x cubed minus 3x squared minus 24x plus 32. So the first step is we need to find the first derivative, because we know that when the first derivative is equal to 0, the function has its relative maximum or relative minimum. So the first derivative is equal to 3x squared minus 6x minus 24. And then when the first derivative is equal to 0, 3x squared minus 6x minus 24 is equal to 0. And then in order to find the value of x, we need to factorize. So simplify first. We get x squared minus 2x minus 8 equals 0. And then factorize x plus 2 and x minus 4. Therefore, x is equal to negative 2 and x is equal to 4. So now, using these values of x, we're going to determine whether the point is relative maximum or relative minimum using the second derivative test. So first we need to find the second derivative of fx. We have that the first derivative is equal to 3x squared minus 6x minus 24. So the second derivative of fx is equal to 6x minus 6. So when x is equal to negative 2, the second derivative of fx is equal to 6 times negative 2 minus 6, which is negative 18. So negative 18 is less than 0. So we can conclude that it is the relative maximum for the function. And now when x is equal to 4, the second derivative is equal to 6 times 4 minus 6, 18, which is greater than 0. So since the second derivative of fx when x is equal to 4 is greater than 0, we can conclude that it is a relative minimum for the function. And now we need to find the corresponding y coordinate for each of the x coordinates. So when x is equal to negative 2, the function is equal to negative 2 cubed minus 3 times negative 2 squared minus 24 times negative 2 plus 32, which is equal to 60. And when x is equal to 4, the function is equal to 4 cubed 3 times minus 3 times 4 squared minus 24 times 4 plus 32, which is equal to negative 48. So our conclusion would be the relative maximum is negative 260 and the relative minimum is for negative 48. So if we were to sketch the graph, this is how it's gonna look like. So the relative maximum is here, which has the coordinates of negative 260, and the relative minimum is here, which has the coordinates of 4, negative 48. So that's all for example 3, question number 1.